Go. Today we're teaching you how to do roots.
Okay, roots they're a number that when multiplied by itself, it's an indicated number of times the product is equal to this specified number.
An example of that would be the square root of 200, and by doing that you'd have to take the square root of 200 and break it up into different pieces. So you break it up into like 4 and 50 because
Square root.
or the square root.
That's important. No, square root of 4 and 50.
Yeah, the square root of 4 and 50, which would make it easier. And because the square root of 4 is a perfect square, so it would be 2, and you'd bring the 50, and then perfect square in the 50 would be 25. So you could break that up, and 2, of course, and then it would be 5, because the square root of 25 is 5, and you bring the square root of 2 down. Oh, this is way too small. So you multiply these two numbers, which is the 5 and the 2, because you broke them out, and then the final answer would be 10 and the square root of 2.
Okay. And exponents are quantity representing the power to which a number or expression is to be raised.
An example would be 4 to the third. You just have to multiply 4 times, which would be 16 times 4. Right, and then you bring the 4 down. 16 times 4, which is 64.
Okay. Perfect squares are when you have a number that can be broken down into the same number, but you can just multiply it twice.
An example, all of the perfect squares from 100 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And
break it down.
Yes.
It would be 64, and then square root of 8, and then 4 and 40. Wait, I just messed that up a lot.
Yeah.
It'd be 8. The answer is you can move on.
The product property lets you take the square root of a product of a number and break up the radical into the product of a separate square root. So, like, you could take the square root of A times the square root of B, and the product property allows you to move those together or split them up. So it'd be A times B. And but the other example would be it would be the opposite of this. So it'd be A times B to the square root, which would then equal the square root of B times A.
The quotient property is the exact opposite of the product property. Obviously, it allows you to split the two square roots between the denominator and the numerator to be able to rationalize it. So you have the square root of A divided by the square root of B can be broken up to the square root of A divided by the square root of B.
And A has always to be greater than or equal to 0, and B always has to be less than 0. And an example would be the square root of x, the square root of x squared y divided by z to the third, which then you could split them up and have the square root on the bottom and the square root on the top. And in cube roots, a number when multiplied by itself is 3 times the equivalent of its cube root. So an example would be 8 times 8 times 8 would equal 512, or 8 to the cube root.
And then to be the opposite of that, you have the square root of 512. That would equal
That's the cubes.
I know, but if you do it backwards, this would be 8 to the third. Going backwards.
And then this graph that I showed here shows the difference between the square root and the squared and the square root. The two are inverses of each other. So this diagonal line that is just y equals x, which is just a regular line. It splits them in two, but actually the square root the y equals the square root of x can never be like this, because that wouldn't be an actual function because of the line thing. But if you look at it this way, it shows that they're inverses of each other because it's rotated in the diagonal line.
How is it? Don't